Hi everybody, welcome to Test 2 review for Calculus 1. As always, the list of the topic that we're going to do is on the top, and some useful formula will be on that side. Right, now let's start. First, we will not do any derivative yet, but we just decompose a function. So turn the page. Right, this is just decomposed function, but we don't have anything like that on the review, but there's something similar. I look at 6 and 7. We're very similar to it. So to decompose a function, so we'll just put something in the box and we decompose. We have the function of the box, and that equal to negative 2x plus 7. Right? I'll just label the box U. Now we decompose the function in two. Right. The first one we don't have to do the topic that we have here. We don't have to find the derivative. But if we do, like in this case, we do need to find the derivative. Then we'll take derivative of each one. Let's take derivative of both. Derivative of u to the 5th, 5u to the 4th power, and multiply negative 2. And that is derivative. And u is negative 2x plus 7. And to the 4th. Right. So if we decompose the function, that's all we need. If we want the derivative, of course, that's going to be that. And most of this problem, when we do the chain rule, we decompose the function into functions, and then we take the derivative of both, and then multiply them. So briefly go through the first one here. Oops. As mentioned before, when we take the derivative of the chain using chain rule, we're going to do this a lot. So now to go back to find a bunch of derivatives. Right. So we start with 2. Right, derivative. This one doesn't require any chain rule or any rules. Just the trigonometric rules. We'll see on that side. So we will write 8 over x is 8 to the x to the negative 1 and 10 secant x. And then we'll take the derivative. Will be negative 8 x to the negative 2. And derivative of secant is secant tangent. So it'll be just that. Because you can write that negative 8 over x squared, but that's good enough. Let's go to 3. 3. We certainly can take derivative of t to the 4th tangent t and square root of t, but let's just rewrite the square root of t. Like that. Right. Next, this requires to use the product rule. By the way, we just rewrite the function, haven't taken derivative yet. Now we use the product rule. Right, we have a product. So let's say u is t to the 4th, derivative of that, 4t cubed. V is tangent of t, derivative of that, secant square. Right, and now we take derivative. Derivative of the product is a product rule. Just on that side. So u prime v plus uv prime. Right. We do that first and then we worry about the rest of the problem later. So u prime 4t cubed v tangent t plus u t to the 4th, derivative of that, secant square, and then derivative of this is 1/2 t to the negative 1/2, and of course the minus in the middle. So that is the derivative. Of course we can rewrite this. Let's just rewrite that. So be 4t cubed tangent t to the 4th, secant square t minus 1/2. The t to the negative 1/2 bring to the bottom to the 1/2. Of course you can also stop here, or we'll rewrite that as a square root, also acceptable. So any of this is fine, or square root of t if you like. Right. So we might have a product rule or a quotient rule, and then there will be something attached to it. I mean, not attached to, plus or minus something, and we just take the derivative separately. Right. That was 3. Right. Or this is also similar to what we just did. So find derivative of this. This will be this question asks for the second derivative, so we have to do derivative twice. So first, product rule here. Right. So first we take derivative. So be that u prime v. Of course, on the test you do not need to write all the details like this. So we have 5 u prime v plus u v prime cosine x. right? So that would be 5 sine x plus 5x cosine x, right? So that is the first derivative. To find the second derivative, we will take derivative one more time. Derivative of sine x is easy. We don't need any rules other than just the trigonometry rule. So not a u, not a v. Right. Yeah. So this u, v are a little bit different than that. So u is 5x, v is cosine x. So u prime 5, v prime negative sine x. Right, so that is another product rule. The first derivative of 5 sine x will be, now this is the second derivative, so we have to distinguish that from the first derivative. So derivative is only those two lines. Now the second derivative, 5 cosine x plus, now the derivative of this is a product rule. The u and v now is, of course, those u and v. U prime v, u v prime. So u prime 5 cosine x, u 5x, v prime negative sine x. And put this together, we will have 5 cosine x and another 5 cosine x. Well, we'll make it 10 cosine x. And then minus 5x sine x. Yeah. So we're going to use the product rule twice. So the first one, the product rule here, and then the product rule for that here. Can separate two steps. Anyway, so that was 4. Right. Let's look at 8. Right, find the derivative of this. We're going to use the chain rule on this one. I put a box around for x plus 2. So this function will decompose into square root of the box and the box equal to for x plus 2. Let's label the box u. Right. Then we can take derivative. Derivative of 4x plus 2 is 4, and derivative of that. For this function, we can rewrite as u to the 1/2, and then we can take derivative of u to the 1/2 is 1/2 u to the negative 1/2. Right, so we rewrite and then take derivative. And show derivative of y is equal to the product of these two functions. When we multiply them 4 and 1/2, so we have 4 and a 1/2 here. 4 times 1/2 is 2. And substitute back in for u, we have for x plus 2 negative 1/2. Of course, we can leave the answer like this, or we can write it under the denominator. This is the 1/2 power, and 1/2 power is equivalent to the square root. So we have that. Right. We can stop it here, here, or here. This doesn't matter. Right. Number 9. I will not find the derivative of number 9, but I just decompose that, and then the rest should be easy. So I will put inside the parentheses, inside the box. In front of that, I will have 5 over the box to the 4th power. Right. Let's label the box U. So I'll take the derivative of each one. The derivative of this is 2, but the derivative of this, we need to rewrite that as 5u to the negative 4. And when we write like that, the derivative is a lot easier to do. So take the derivative of this, and multiply them. That is the chain rule. Right, I'll let you do that. So it's 9. Of course, you will complete that problem. Right, I'll look at, I'll do 10 and maybe 11. Right. For this one, usually when we have a trig function that goes to the power like this, I will rewrite it as cosine of pi t minus 11 and then to the power of 4, because we need to calculate the trig function first and then we do the power. Right. Now with that, we will use decompose the function. Right. So first, I will put the whole thing here inside a box. So we have the box equal to cosine of pi t minus 11, and then in front of that we have the box to the 4th power. Right. Let's label that u. Right. Certainly the derivative of u to the 4th is very easy to do. Derivative of this, not yet. It's still easy, but we still need to use something else. So what that something else is, put this in another box. So we have the box pi t minus 11, and in front of that cosine of the box. Label that v. So pretty much this function we do not take the derivative yet. It is the chain rule, so decompose that again. Now we take the derivative of this. 4u cubed times cosine of v negative sine v and the derivative of that is a pi derivative of t is 1. Constant in front of that is a pi, so we have that. So multiply all of this together with us the derivative of y. So let's write the pi and negative sine v in front of that. So negative pi sine v. Actually, there's a 4 in front of that too, so it will be negative 4 pi sine v, and then u to the cube. U cube. That's much better. So we have negative 4 pi sine of v is pi t minus 11, and then u cube. U is that. We can write that as a cube, or we put a cube here. Right. So that is that. 10. Right. I'll do 11 as well. Right. Right. So that was 10. Now 11. So I put this in the box inside the parentheses. And in front of that, the box to the negative 6. Label that u. Right. Derivative of this one easy to do. Derivative of this also easy, but notice that we require to use the product rule for this one. So we have the box is at in front of that sine of the box. Right. Derivative negative 6 u to negative 7 times derivative of 1 is going to be 0, so going to be 0, and then the derivative of this is the cosine v times 8. So pretty much that. There should be a 0 and then plus. Just put that in pencil. So yeah, really don't need that. So that is the derivative. Right. So the derivative is equal to that. Now let's simplify. 8 times negative 4 is negative 48. And then we have u to the negative 7 cosine of v. U to the u is this. And then cosine of v. And so we have that. Right. So that was 11. Next, we go to uh, application. So here we have the position function is just a function, and now we find speed and acceleration. So the speed is the magnitude of the derivative. So we have the original function is this one. We'll take derivative. The first derivative gives us the velocity, which is the first derivative. So we take derivative negative 3t squared plus 4t minus 2. Right. The question asks us the speed at the end of the interval. So we put 2 into it. The end of the interval is t equal to 2. So we're going to put 2 in for t. So just do that. So we do that. Negative 12, negative 14, plus 8, so negative 6. So we have negative 6, and the unit will be meter per second, but we want to find the speed instead. So the speed is the absolute values of the velocity, so it won't be 6. Right. Now we find the acceleration. We take the second derivative. Acceleration is the second derivative. From here, negative 6t plus 4, and at t equal to 2, the end of the interval. It's going to be positive 8. Sorry, negative 8. Yeah, so we have that. So the speed is 6 and the acceleration negative 8. So will be the first one here. Right. Next we have implicit differentiation. Right. Right, so we have this one. So implicit differentiation. First, the question asks us to find dy over dx, which means y is a function of x. So when we take derivative, it's going to be with respect to x. So now we differentiate. With respect to x. Now, derivative, we do for each one of them. This one will be negative 2y, but because y is a function of x, so pretty much we're going to write, instead of that, we're going to have like the box square, where the box is y and y equal to something. So it is like that, like the chain rule. So derivative to y square and then derivative of y. So we're going to have y prime. We can also write dy over dx. Right. Derivative of 1 on the other side, this is just a constant. 1 is a constant. Derivative of constant is 0. Right. So notice that y is a function of x, so we have to have this. Next, this requires to use a product rule. So u is 2x, v is y. So u prime is 2. Derivative with respect to x, just that, but derivative of v is going to be y prime. Right. So we have a product rule. U prime v, u v prime plus, sorry, kind of square me here, u prime 2 y of v is y plus u 2x v prime is y prime. I'll put that in red. So to clear this out, we will have 2y plus 2x, and then there's a y prime, and then minus 2y, and there's the y prime equal to 0. So the negative y square gives us this, and 2xy is the product rule. Derivative of 1 is 0. Right. Now we just move the 2y to the other side because we solve for y prime now. I want to write y prime instead of dy over dx because it's more compact. Now both of these have y, we can factor out y prime. And we have negative 2y on the other side. Finally, we solve for y prime. So y prime equal to negative 2y. We're going to divide by 2x minus 2y. Right. We can clear the answer like that, which is perfectly fine. Or we can also factor out the 2. So cancel out the 2. We can also multiply negative 1 top and bottom. So the top becomes y and the bottom becomes y minus x. But that should be enough. Right. We will go to 13. Right. 13. Notice that once again y is a function of x, and we take derivative with respect to x. So let's just write. That's what we remember. So y is a function of x. Now we take derivative with respect to x. So differentiate with respect to x. So on this side, x to the 7 give us 7 x to the 6, and with respect to x, so that's all we have. Now cotangent y, because y is a function of x, so we kind of have to have like that. Y is a function of x, so derivative is going to be derivative of cotangent is negative cosecant square of y, and then derivative of that, and then derivative of y will be y prime. So that equal to, right? So now we solve for the y prime. So y prime be equal to 7x to the 6 divided by negative cosecant square y. Right. Of course, we can also rewrite that as negative 7x to the 6. 1 over cosecant is sine, so we have sine square y. Yeah, so any of this is acceptable. Either one is fine. Right, so we have 13. Right, so that was 13. Right. I would do 14 as well, but I think we did this in class, so I'm not going to do that again. But just a little hint here, it would be a lot better before we jump right into derivative. We square both sides. So we have y squared x plus 1 equal to 16, or xy squared plus y squared equal to 16. Now when you write like that, derivative will be a lot easier without the square root. So we do like we did earlier, and because we did this in class. Right, I will go to 15 instead. Right, 15, on the test you will have either this kind of question or we ask for the equation of tangent line. So if we need the equation of tangent line, it's going to be that. So now the first thing is the same thing as before. We have y is a function of x, and we have this is u, that is v. So let's just say y is a function of x, and then differentiate with respect to x. Right, so u prime, u is x to the 4th, v y to the 4th, u prime for x cubed, v prime for y cubed. But since y is a function of x and we take derivative with respect to x, we have to have the y prime next to it. We always have to have the y prime because after all we're going to solve for it. If we don't have it, we cannot solve for it. Right, so the left hand side is the product rule. The right hand side is a constant, derivative is 0. So we have u prime for x cubed, v y to the 4th, u v prime right? So multiply this, we have 4x cubed y to the fourth. I should always keep the y here in red because that's what we're gonna solve for, right? So that will be 4x cubed, 4x to the fourth, y cubed, and that will be y prime. Y is a function of x, so we are the chain rule, always have this. Now we'll get the y prime by itself, move this to the other side. And then divide. So y prime equal to so a lot of things cancel out, so we just have negative x cubed and x fourth cancel. We have x at the bottom, y fourth and y cubed, we have y on the top, so we have negative y is 1, x is 2, so we have negative 1/2. So here we have at x equal to 2, y equal to 1, and so we substitute in, and that's what we have. Right, so that is the slope. Have knowing the slope, we can find the equation of a tangent line. The equation, of course, on that side. Right. Next, we evaluate the rate. Now we go to related rates. Let me update the list. Let's find out. Now we go to related rates. We have 16. Right, 16. Now it's going to be different than the implicit differentiation. Now we assume that both x and y are function of t. So both of them require the chain rule. Let me rewrite the problem. Right, now we take derivative. Now since x is a function of t, so we're going to have the box like x, and then the box equal to a function of t. So we take derivative of x is going to be 1, and then derivative of the box, we're going to have x prime. I should write x prime, but because we have 3 variables here, x and y depends on t, so we have to have it's better to write the x over dt instead, so it's less confusing, right? That, and on the other side, derivative of 12 is going to be equal to 0, a constant still 0. This required a product rule, so u equal to x, v equal to y. Derivative of u, just like this, is going to be 1, and the x over dt, and derivative of v is y, which is 1, and dy over dt. So in front of that, we have Right, so x times dx over dt, and then sorry, don't have enough space. Right, u prime v u v prime, and then this will be 1 dx over dt, derivative of 12 is 0. Right, u prime 1 dx over dt times v will be y plus u is x, v prime be 1 dy over dt. Let's clear this out. Simplify this. Y dx over dt plus x dy over dt plus dx over dt equal to 0. Next we have these values. And we substitute in. Y is going to be 5. Dx over dt is negative 3. X is 2. Dy over dt, we don't know that, but that's alright. We're looking for it. Plus dx over dt, negative 3. Notice that the plus and the plus here. So we will have negative 15, negative 3 more than that, to negative 18. So move the 18 over. And we have 18 over 2, or 9. Right. So notice that in this related rates, the problem with related rates, x and y and any variables are function of t. So in that case, we have to have dx over dt when we have x, dy over dt when we have y, and whatever the variable is, we have to use the chain rule. Right, so that was 16. Right, next also on related rate, but we do a work problem. Let's look at number 17. 18, not going to do that because I think we did one very similar problem like that on in class. Right, water is discharged from the pipe at the velocity given by that. So we have the equation. So always, it's nice to have the equation. Next, we assume that everything a function of t. So I said if we have the problem, just go ahead and take the derivative. We'll worry about everything else later. So the derivative of v, notice that both of them are function of t. So we need to write that. So everything is function of t. By everything, I mean v and p. So when we take derivative of v, it is just 1, and then dv over dt equal to that is 1/2, and p to the negative 1/2 dp over dt. Right, simplify dv over dt equal to 1106 divided by 2, 553, and dp over dt. Right. So if we have the equation, just go ahead and do this. Worry about the rest of the problem later. Right. Now we look at the problem. So we have the equation. V is the velocity, so we just underline some important things. And P is the pressure. The pressure is in the psi, pound per square inch. If the water pressure is changing at the rate of 0.162 psi over second, so very important that we have that number psi over second. Psi is the unit of the pressure, and second is the unit of time. So this pretty much is going to be dp over dt. So it's equal to 0.162 psi per second. So that's what we have. Next, find the acceleration dv over dt. So we're going to find this. We don't know what that equal to, but we do know the pressure is at 43 psi. So we know pretty much. Put a check mark. We know the pressure. We know the dp over dt. Pretty much we put everything in 553. P is 43 to the negative 1/2. dp over dt is that. So I have a calculator here too, so oops. Right. 553 times 43 to the negative 1/2, and then times 0.162, have 13.66. 13.66, and we have the velocity is feet per second divided by another seconds. We have feet per second square. So it's going to be that. So it's nice to have the equation, and then we just jump right in and take the derivative, and after that we determine what we have and what we don't, and we just solve for what we don't have. It was 16. We did a problem similar to 18 on in class, so I'm not going to do that again. Right. Right. Next, we go to the critical points. So we take a look at 19 and 20. So 19. Right. 19. So critical point. Let me write out what we need. So for critical point, we need to have two things. First, the function, the derivative that is equal to 0 or does not exist. Second, it must be in the domain. So f of c is defined. So a critical point C is where the derivative equal to 0 or does not exist, or the function is or the derivative does not exist. Derivative is equal to 0 or does not exist, but the function, original function, has to be defined at the point. So that gives us the critical point, meaning C is in the domain. Right, so we need those two things. So pretty much we have to take derivative. Give us 3x squared minus 18x, like that. And now we have two things, derivative equal to 0 or derivative does not exist. In this case, this will be simple. 3x squared minus 18x equal to 0. Factor out 3x. So I have x equal to 0, x equal to 6. We have 2 points. Over here does not exist. This is a continuous function. A polynomial is continuous and defined everywhere, so we do not have anything for this case when it does not exist. Bottom line is we have those 2 points. Now we just need to make sure that the function is defined. So do a little check. At x equal to 0, if we put 0 in the original function, it is defined, and so we don't have to evaluate that is equal to 4, but just say it is defined, which is good. So that is good. Now we check for 6 with the original function. Of course, that's going to be defined as well. So that also check. So derivative equal to 0 does not exist and in the domain. So in this problem we have critical point, x equal to 0 and x equal to 6. Right, so that was 19. Right, next we'll go to 20. So before I take derivative, I will rewrite that as 4x squared minus 128 x to the 1/2. Right, now we'll do it. Find derivative. Derivative of this is ax minus 128 x to the 1/2. Derivative of that is 1/2 x to the negative 1/2. Right, simplify this. Ax 128 and 1/2 is 64. X to the negative 1/2. Right, now negative 1/2, move it down to the bottom. Turn to positive. Right, now we have something at the denominator. When that happened, we will convert that into one big fraction. So sorry, not here, but the other one. So I multiply the ax, x to the 1/2 top and bottom to have the common denominator of x equal to 1/2. The top we have ax times x to the 1/2 will be ax to the 3/2. 1/2 and 1 is 3/2 minus 64. Right, so that is the derivative. Right, now just like the last problem, we need derivative equal to 0 or derivative does not exist. Now we have one fraction, derivative equal to 0, that equal to 0 if the top equal to 0 and does not exist if the bottom 0. Right, so now we do that. This move the 64 over divided by 8. We have x to the 3/2 equal to 4. So 64 over 8 is 4. I mean 8. Sorry. And we rewrite that is x to the 3/2. If we rewrite in the radical form, will be x cubed and square root 8. Right. Now to get rid of the square root, we're going to square both sides. So it gives us x cubed equal to 64. And then to get rid of the cube, we take the cube root. So we have notice that when we take the cube root on both sides, we do not need to have plus or minus. So we have cube root of 64, which is 4. Right, so x equal to 4 on that side. On the other side, x to the 1/2 is equal to 0. This is easy. Anything raised to different power than 0 is 0. The base must be equal to 0. So we have 0 and 4. And finally, we need to check to make sure that both of them are defined. So check at x equal to 4. We put 4 in the original function. 4 square minus 128 square root of 4. So this is perfectly fine. It means where 4 is 2, so we can do that. So this is defined. So this one's good. And we do for 0 the same way. So critical points, those two. Right, so that was 19 and 20. Right, next we find absolute maximum and absolute minimum. We have 21 and 22. Look at 22. Find the absolute maximum and absolute minimum in this interval. So this interval is going to be plus negative 27 and 1. Alright, so to do this problem, let me write out the steps. So first, find the critical point, but not really critical point. We just find C such that derivative equal to 0 or does not exist. That is not critical point because critical point requires that C is in the domain. We don't really need to check. No need to check. And then we just evaluate in the original function. I just write in shorthand notation here. So those are pretty much the two steps, and because the biggest one is the max, the smallest one is the mean. Right, so we take derivative. B5x sorry, 5 times 2/3 x negative 1/3, which will be 10 over 3 x to the negative 1/3, or 10 over 3 x to the 1/3. Right, so that is the derivative. Right, so we will let derivative equal to 0 or does not exist. Which means for fraction, top is 0 and this the bottom equal to 0. The top is 10 equal to 3, equal to 0. Obviously this doesn't work, so we do not have anything here on that side. On this side we have 3x to the 1/3 equal to 0. Divide by 3 on both sides. Have this, pretty much x equal to 0. So pretty much we just have one point, x equal to 0 here. And here we have nothing. Right, so the first step is find all the values that the derivative equal to 0 or does not exist. We have x equal to 0. Notice that this is not a critical point. We don't really have to check yet because we're going to check it later. Actually, we're going to check it now. So now next we evaluate. Make sure that very important with the original function. So we have a table. The values that we evaluate will be the endpoint, negative 27 and 1, and then any point that we have here, actually just 0. So we have those 3 points for x, and the original function 5x to the 2/3. This is not derivative. Use the original function. That is very important. Now we just do that. I'll use the calculator on this one. Right, I will hit the stack, go to the list, and we will have the values of negative 27, 0 and 1. Right, and then when I go to L2 and I have to highlight the L2, so have to highlight the L2. With L2 highlighted, I enter the original function. Original function is 5x to the 2/3. So instead of x, we use L1. To hit L1, we're going to hit the second and number 1. So second, number 1, and then to the power of 2/3. Hit enter. So we have those values, 45 here, 0 and 5. So we find where the derivative equal to 0 or does not exist. And then we evaluate in the original function when we evaluate any point we found along with the boundaries. So when we look at this, obviously this is the maximum, and this is the absolute minimum. So let's write absolute max equal to 45 if x equal to negative 27, and absolute min at x equal to 0. So pretty much that. Right, pretty much that. Right, so derivative equal to 0 does not exist. Find those values along with the boundaries. Check them. The biggest one is the max, the smallest one is the mean. Right. Now we have the absolute extremum done. 22. Right. Next we will go to the where we have the derivative. The first derivative will tell us if the function is increasing or decreasing. And with that we have the local max and local mean. Right. 23, 24, and 25, there will be the similar thing. Right. So I will look at first at 23. So to do this, we do like we normally, like what we just did, find the critical points. Not really critical point, just where derivative equal to 0 or does not exist. Right. So this is the function, and let's use the quotient rule here. Right. You might want to write this one small and divide this into 2 columns. Derivative is the quotient rule. U prime, just write the quotient rule. U prime v minus u v prime over v square right, and simplify this. We will have 0, so negative 2x on top, x squared plus 1 or that square at the bottom. And now we do two things. Equal to 0 does not exist. You will see we do a lot of this. Equal to 0 meaning the top is 0 and does not exist, bottom is 0. So negative 2x equal to 0, x equal to 0, x squared plus 1 squared equal to 0. This doesn't give us anything because x squared plus 1, x equal to plus or minus square root of negative 1, which is plus or minus I. Imaginary doesn't count, so pretty much we do not have anything here. So pretty much nothing on that side. Right. So pretty much we'll have only one value, says x equal to 0. That's where we put in the sign chart. Right. Next is the sign chart. We have x and then the derivative is this, so negative 2x over x squared plus 1 squared. That is the derivative. Now we only have one point, x equal to 0. Right. So since there only one point, so it will divide the number line into sub-interval. Next we use the test point. So the test point, we're going to pick a numbers between here and the numbers between there. I choose negative 1 and then 1. I put in the parentheses to distinguish with the point that I divide the number line. Right, back to calculator. Right, I hit start. Sorry, turn it on. Now we clear the list first. To clear a list, we highlight the list that we want to clear. So highlight L1, hit clear, and then enter. So clear, enter. That's clear. Now highlight L2, clear, and then enter. Now the values we evaluate is negative 1, so negative 1. This negative sign and not the subtract. Negative 1 and 1. Now we will evaluate the function. Actually, this is the derivative. So highlight L2 and enter negative 2. L1 for x divided by L1 square plus 1 square. Right? And we have positive and negative, right? So positive and then negative. Positive for negative 1 and negative for negative 1, right? Next, if it is positive, derivative is positive, the function is increasing. It's negative, the function is decreasing. The question asks us the function is decreasing. So it is decreasing for this interval. Yeah. So we find the derivative where it is equal to 0 does not exist, and then find those points, put on the number line, divide the number line, choose the test point in between, and then test them. Positive is increasing, negative is decreasing, and the question answers for decreasing. So it's going to be that. Right. So that was 23. Right. Next, find the local extrema of the function if they exist. This will do the same kind of the same thing as before. Right. Right. Still an application of first derivative. So we take the first derivative for x cubed minus 4x. Right. And we do two things: equal to 0 do not exist. Except on this one, it is a polynomial. Polynomial is continuous everywhere, so it is defined everywhere. So we do not have anything here. Here we have for x cubed. Right. Right. Of course, we can use the that f. So if we hit app application and go to this, I have to use this calculator instead of the one on the computer. The one on the computer doesn't have that option, doesn't have that application. So polynomial and simultaneous equations, right? And a polynomial root finder. This is the third order. Just leave it like that is fine. The answer in fraction. And so yes, everything good. Then just hit next. This key. Now the coefficient is 4, 0, negative 4. Notice the negative and not the minus. And 0. And then we just hit solve. We have that. So negative 1, and 0. Of course, we can factor out for x. So we have x equal to 0 and x squared minus 1 equal to 0. So x is equal to 0 or x equal to plus or minus 1. Right, so we have those points. Right, usually we will check to make sure that those points are defined, meaning we need to check to make sure that those are the critical points, but we can check that later. Now we're going to put on the sign chart. Right, x. On the sign chart here we use the derivative for x cubed minus 4x. Right, the point we have 0, negative 1, and 1. Just need to put them in the right order. Negative 1, 0, and 1. The scale doesn't matter here. right? And we should have on the number line, so this is negative infinity, infinity, right? Now, so those number divide the number line. The test point has to be in between, so I will choose negative 2 here, negative 0.5, 0.5, and 2. Choose the test point in between the interval, right? This we use the calculator again. Right, so go to list, and now we enter the values. Just clear this list first. So highlight the L1, clear, and highlight L2, clear, and enter. L1 is those values, the test point, negative 2, negative 0.5, 0.5, and then 2, right? The function, when you enter the function, L2 must be highlighted. And now we enter 4x cubed for L1 cubed minus 4L1, and we have those numbers. We just need to know if it is positive or negative. So we have negative, positive, negative, and positive. So negative is decreasing, increasing for positive, decreasing, and increasing. So when it goes like this, we know that it's going to be the minimum here, a max here, and the minimum here, because it goes like that. Right. We keep the calculator. We're going to use the calculator a bit later. But now we just write local max equal to, we don't know what that is yet, just leave a blank space, but we know that it is at x equal to 0. So that's what we know. Local max at x equal to 0. Local, we don't know the values. That to be determined. Next, local mean. Don't know what that is, but we do know it is at x equal to negative 1, and there will be another local mean that occurred at x equal to 1. Right? We don't know those values, and those values will come from the original function, because those are the y values. So those are from the original function. Right, back to the calculator. Now let's clear the list. Clear, and clear, and now we evaluate at those values 0, negative 1, and 1. We want to find the values in the original function. So while L2 is highlighted, the original function is what? X to the 4th minus 2x squared minus 9. So with L2 is highlighted, L1 to the 4th power minus 2 L1 squared minus 9, hit enter, and we have at 0 it is negative 9, at negative 1 it is negative 10, and at 1 it is negative 10 as well. Right. Yeah. So note that the local max or local mean, or absolute max or mean for that matter, on the maximum point, minimum points point on the function. So it must be from the original function. We can find that later. On the sign chart, we use derivative to test the sign chart with the test point. Yeah, so those form the original function. Right, so that was 25. Right. So those application for derivative. So the sign charge on derivative will give us decreasing, decreasing, and from there we can find maximum, minimum, local max or local min. Now we go to the second derivative. Will give us concavity, concave up, concave down, or point of inflection. Right. 26. This problem asks for the concave down and concave up. So that is where we use the second derivative. Right. So first derivative 3x squared minus 6x plus 2. Right. And then we take the second derivative 6x minus 6. Now, pretty much like what we have before, second derivative equal to 0 or does not exist. X. And here we have none because polynomial function is defined everywhere. 6x minus 6 equal to 0, so x equal to 1. Right. So we have just one value, x equal to 1. And then we put in the sign chart similar to the one with the first derivative. But this time we use the second derivative. The second derivative 6x minus 6. The point we have is 1. That divide the number line is 1. So cut the number line in 2. Next, the test point. And we choose a point in between the interval 0 and 2 will do. And then we put those points into the second derivative. Put 0 in here, we have negative 6. Put 2 in here, we have 6. So that's easy. We don't really need the calculator for this one. Right. Now, for the second derivative, if the second derivative is positive, the function is concave up. If it's negative, the function is concave down for the second derivative. So this one, it is negative, so concave down. Positive is concave up. So we say concave up from 1 to infinity, and concave down from negative infinity to 1. Yeah, so that's what the concavity gives us, the second derivative. That's what the second derivative gives us, the concavity. And from there we will have the point of inflection point, that is. 27, will not do completely 27, but I just write the derivative. So the function is this. So people put a box. So the derivative equal to that is 3u to the negative 1. So derivative is negative 3u to the negative 2 times the derivative of this. It's just 1. So we have negative 3 x plus 2 to the negative 2. Right, so that is the first derivative. Of course, we can rewrite this as a rational function, but it's better just keep going with this. So I have another box. And we'll take the second derivative. So that will be positive 6 u to the negative 3, and that is just, again, it's just 1. So we have 6 x plus 2 to the negative 3, which is of course 6 over x plus 2 cubed. Alright, so that is the second derivative. And then we do two things like we did before. Equal to 0, and does not exist. Here we have nothing. Here we have that. Right, so we have negative 2. Next we're going to do the sign chart and test with the second derivative this function. I'm not going to do that. So that is 27. Not completely finished that, but yeah, when we have this, we do the sign chart. That should be easy. Inflection point. Inflection point is also the second derivative. That is the second derivative. So we find the second derivative. Of course, let's do that one step at a time. 6x squared plus 24x plus 18, and then the second derivative, 12x plus 24 alright, and then the same thing, equal to 0, does not exist. I do see the pattern here. We did a lot of this. So we only have negative 2. Polynomial function always defined, so we don't have this. Although this is the point of inflection, we really still need to do the sign chart, because we not just find a point. We have to know that it actually have some other properties. Right, so still the sign chart. the point is -2. Number line, oops. Right, test point, I choose 0, and sorry, 0 should be here, and here I should choose -3. Sorry, the -2 will divide the number line. Right. So before we do this, just go back to where we have the inflection point. So inflection point is where it's equal to 0 does not exist. That's not important. The important things about inflection point is that for inflection point, the only thing that matters is the concavity. We change the sign, or we just say changes. By that we mean concave up to concave down, or concave down to concave up. So inflection point is where the concavity changes. Right, so we do that. Put in 0, we have positive. Put in -3, that would be negative. So here negative concave down, positive concave up. Right. We need to do the sign chart so we can say the concavity change from negative to positive, from concave down to concave up. So from here to there, concavity changes. So we say inflection point x equal to -2 and y equal to, we still don't know that. But if we want the y values, it must come from the original function. So inflection point maximum or minimum must be a point on the graph. That means it comes from the original function. Right. Calculator. Right, so I need to have x equal to -2. So don't need this anymore. -2, and I will store STO key into x. Now the x will be -2. I just need to evaluate the function to x cubed plus 12x squared plus 18x, and I have -4. So once again, max, min, inflection point, all those points must come from the original function. So we check with the original function. So x -2, y equal to -4, that is the inflection point. Right, so that was that. Right, second derivative test. I'm going to write important things here. So second derivative test, we're going to have the following. First, the derivative, this is the derivative, must be, that should be c, not x. That means at the point. The derivative must be equal to 0. Not exist. This one has to be equal to 0. So that. And then after that, the second derivative, if it is positive, it is concave up, and if it go up like this, we have the lowest point, so that would be minimum. If the second derivative less than 0, it concave down, and that's the highest point, so it will be a max. And if it equal to 0, it is inconclusive. In that case, we cannot use this anymore. We have to use this to determine the maximum minimum. Right, now just do this. By the way, for this problem, the point will be given, so we don't have to find it. Just want to test them. So first, derivative equal to 6x squared minus 6x minus 12, and now we're going to put 2 in it. So at x equal to 2, the first derivative equal to 6 2 square 6 2 minus 12. So 4 6 24, so that is 0. So that means that is good. The first one check, which means x equal to 2 is a critical number or critical point. If it is not, then we're just going to choose not the critical numbers, and the problem is done. Don't need to go any further. Right, now the second derivative is going to be 12x minus 6. Now we're going to put 2 into it. And that is positive. Positive is concave up, so there will be a minimum. So we have critical number and minimum. So that will be the answer. Of course, so we know that at 2 it's going to be the minimum. To get negative 2, we have to put it back into the original function. But we don't need to do this. We just say that the minimum at x equal to 2, and that will be enough. Because the question asks us to classify what happened at 2. We don't need to find it. So we say minimum at x equal to 2. That will be enough. And that is the local mean. So yeah, that will be good enough. So that's what the second derivative will tell us. The advantage of the second derivative is that we do not need to do the sign chart. We just test one point. The disadvantage of that is it could be inconclusive, and it might potentially does not exist where it doesn't work here. Right, so second derivative test, we just test the point, and the points are given. So that is straightforward. That was 28. Uh, 29 will be very similar to this, so I don't think I need to do that. Right. Sorry, this review is a little bit longer than the first review, but we did go over a lot of things. I do hope that it helped you to prepare for the second test. Thanks for watching.